So this is the third in the set of History of Science lectures in honor of Michael Nauenberg. And I'll just say a few words about Michael. Michael was born in, I think, 1934, right? To a secular Jewish family in Berlin. And in 1939, his family emigrated to escape the Nazis to Barranquilla, Colombia. In the 50s, he moved to the US and he studied at MIT and got his doctorate at Cornell University working with Hans Bethe. He did his thesis on particle physics. He then became a visiting fellow at the Institute for Advanced Study. He was an assistant professor of physics at Columbia. He was a visiting professor at Stanford. And then in 1966, he joined the faculty at UCSC and was one of the founding faculty in physics, not only playing a crucial role in the physics department, but also instrumental in developing Stevenson and Crown colleges. He retired in 1994, and at that time became very interested in the history of science, or he probably was interested before, but he devoted a lot of his effort at that time to the history of science, especially the works of Newton, Hooke, and Huygens. And in 2013, he received the Constantine Panunzio Distinguished Emeriti Award for his influential work on the history of science. Now that just sounds like, oh yeah, I got another honor. But in fact, the Panunzio Award is only given to faculty or emeriti in humanities or social sciences. So for a physicist to get this award is quite amazing, and it wasn't for his work in physics, but his work in the history of science. So when Michael passed away in 2019, the UCSC Emeriti Association and the Nauenberg family established this History of Science lecture series in his honor. And as I say, this is the third of hopefully a long line of really excellent talks. So the speaker today is Jessica Riskin, who is the Francis and Charles Field Professor of History at Stanford University. She received her BA from Harvard, her PhD from UC Berkeley. She taught at MIT before coming to Stanford and also at Iowa State and Sciences Po in Paris. She's the author of a series of very well-regarded books. One is Science in the Age of Sensibility, which won the American Historical Association's J. Russell Major Prize for Best Book in English on any aspect of French history. She was the editor of Genesis Redux, which is essays in the history and philosophy of artificial life, and co-authored with Mario Biagioli, Nature Engaged, Science and Practice from the Renaissance to the Present. She's also the author of The Restless Clock, a history of the centuries-old debate over what makes living things tick, which won the 2021 Patrick Suppes Prize in the History of Science from the American Philosophical Society. I can't say that I've read all of her books, but I did read The Restless Clock, and I was so impressed that I definitely wanted to get her here to give a talk. And her talk today is Professor of Insects and Worms, Jean-Baptiste Lamarck and His Life-Made World. Jessica.
Well, thank you so much for that. Thank you for that lovely introduction, and thank you, Eli, for this invitation, and Christy for setting everything up so beautifully. And I want to say it is really a great honor to be this year's Nauenberg lecturer and to meet Michael Nauenberg's family and have them here. It's really an honor. So this on the slide, that's my protagonist, the professor of insects and worms in question. Jean-Baptiste Lamarck, he was the Romantic era and Revolution era French naturalist who, you may be interested to learn, invented biology in the sense that he coined the word biology. Around 1802, he thought that there should be a science devoted to all living things and only living things, and that was a new idea. There were sciences devoted to, there was botany, there was zoology, there were different there was natural history, which included rocks and rivers and things, but his idea was that there should be a science just of life. And so you see on the slide on the left side his first writing of the word, and on the right, the first time that it's in print. And he also developed the first theory of what we now call evolution, although he didn't use that word. So, let's say transformation of living forms, or we can call it transformism, is kind of a more approximate word. So I'm currently working on an intellectual biography of Lamarck that follows his theory of life. First of all, follows his own life and science, and then after he dies, there's a whole part of the book that follows his theory of life through the end of the 20th century and even up to the present, which is a hazardous business for a historian, but I'm trying it. And so you may have heard of, we were talking about this a little bit before, if you've heard of him, you probably immediately think of giraffes. And he's the guy that was wrong about giraffes. I'll come to giraffes in a minute. But first, let me just say why I think that he is interesting and important enough to write a book about. His ideas, as I've been saying, were foundational to modern biology, and yet his approach to living things was radically different from the dominant tradition in evolutionary biology that took hold at the, around the end of the 19th century, turn of the 20th, and I think is very much still with us today. And so Lamarck's theory kind of languished mostly in exile or on the fringes of mainstream biology for over a century, between roughly the 1880s and 1990s, when some of his ideas began slowly re-entering the mainstream. And this is a complicated question, but anyway, I would say that Lamarckian sorts of ideas have come back in several areas of biology recently, in possibly in epigenetic inheritance, in ideas about niche construction, in ideas about behavioral factors in natural selection, in various ways. So that's something I'm happy to talk about later on. Lamarck's theory differed from the main tradition of later evolutionary biology in a couple of ways. First, in terms of the agency that he ascribed to living organisms. He described these as continually creating and transforming the world, themselves and the world around them, presenting a kind of proto-ecological vision of a world made by living organisms, which were, according to Lamarck, the only creative forces in the world. To live, he said, was to create, to compose, to take elements and build them into compound matter. The dominant tradition in evolutionary biology, in contrast with that, has rendered living organisms as fundamentally passive, subject to random genetic variation and natural selection, so essentially passive. And secondly, in keeping with his view of living things as actively making and remaking themselves and the world, Lamarck's mode of scientific explanation was narrative and holistic, dwelling in the desires and actions and behaviors of living beings. He rejected the model of scientific explanation that his contemporaries were establishing as the reductive account of a fundamentally passive artifact world. And so I think his ideas can give us a perspective not only on the history of biology and evolutionary theory and conceptions of living organisms, but also more fundamentally on science, what it is, what it isn't, and how it came to be that way and what it might otherwise be like, how we could imagine it in other terms. So finally, coming to the giraffe, when I was studying biology in high school and college, my teachers and the textbooks that we used took Lamarck's observations about the giraffe to epitomize his theory and how mistaken it was. So here's what he had to say about giraffes. He basically has two short passages, which are essentially the same as one another. So here's from his magnum opus, the Philosophie zoologique in 1809. Concerning habits, it is curious to observe their results in the particular shape and size of the giraffe. We know that this animal, the largest of mammals, inhabits, he means the tallest of mammals, inhabits the interior of Africa, and that it lives in an area where the terrain, being almost always arid and devoid of grasses, obliges it to graze the leaves of the trees and to struggle constantly to reach these. The result of this habit, maintained over a long time in all individuals of the race, is that the front legs have become longer than the hind legs, and the neck has elongated itself such that the giraffe, without standing up on its hind legs, lifts its head and attains a height of 6 meters, almost 20 feet. So the key word in that passage is actually not giraffe, but habits. Lamarck said that animals capable of forming habits could, by doing that, transform their physical forms in tiny, just very, very tiny incremental ways, but that then these would be inherited and added together, accumulated over many generations. That claim provoked what must surely be one of the longest-lived controversies in the history of science, because over 200 years after the publication of the Philosophie zoologique, the idea that living organisms might transform themselves by their own agency in heritable ways remains a hot-button question in evolutionary biology. So why is that? Why would that be? I think the very short summary answer is that it violates a core principle of modern science established around the end of the 17th century, which precludes in principle, although I think people often violate this in practice, but in principle precludes any ascription of agency to natural objects, including living beings. So Lamarck's ideas about habits violated this injunction on agency in natural objects and in scientific explanations. I actually came to Lamarck through a book, the book that was mentioned very kindly, The Restless Clock, a few years ago, when I examined the origins of this passive mechanist model of nature, and in particular of living things. And so the book is about a struggle between two approaches to the science of life. One representing living things as passive mechanisms that have received their structure and mode of functioning from an external source. In the first instance, it was a divine designer, according to the 17th and 18th century versions of the theory. And the competing model, which emerged in the mid to late 18th century, especially in France, that represented living beings as active, self-making, self-transforming kinds of machines, living machines. And I examined the politics of this struggle in which the active mechanism approach represented a far more radical threat to the traditional theological understanding of natural history, because it sort of usurped God's monopoly on creation and reassigned it to mortal beings. So Lamarck's theory was the crowning achievement of this alternative, centrally French materialist tradition. Instead of appealing to an external source of agency, as in the theological argument from design and this classical mechanist physiology, Lamarck said, first of all, that living things originated in spontaneous generation, triggered by forces like electricity and heat acting on inanimate matter. Very rudimentary forms of life would be generated by this, and then once generated, living matter, he said, tended to complexify, kind of ramify and complexify by a force intrinsic to it that he called the pouvoir de la vie, the power of life. And this was, in his imagination, just like other natural forces, like electricity, magnetism, gravity, the inanimate matter in contemporary physics was full of forces and tendencies. And Lamarck thought that living matter had its own, which was this tendency to complexify. Oh, sorry, I got a slide behind. So as organisms became more complex, which is what you see on the right side, so this is Lamarck's first chart of this process happening. He did various different charts, but this one is from the Philosophie zoologique in 1809, his big, where he first presented this theory to the world. And so you see that the organisms are, the rudimentary simple ones are at the top, and they become more complex as they go down, which is different from later evolutionary march of progress charts. So as organisms become more complex, another cause of transformation begins to act, which is responsiveness to an environment. And in lower organisms, this responsiveness takes various primitive and rudimentary forms. But from, he says, the level of birds and mammals, the responsiveness can take the form of acts of will. These are intelligent beings, and they can form, by acts of will, they can form habits and ways of life in response to their circumstances. And so not only did he place evolutionary agency within the evolving organism, but he described the process of transformation over generations as a transfer of agency from outside to inside. He said, as nature transported into the interior of animals the forces of transformation, placing these increasingly at their disposal. And Lamarck thought this must be the case because he said if each creature owed its organization purely to an external source, then animals would be, he said, totally passive machines, lacking sensibility and what he called the intimate sentiment of existence, with no power to act, no ideas, nor thought, nor intelligence. You would never get those things from totally passive machines that were shaped from outside. He went even further. Not only, he said, did living organisms create and transform themselves, but he also thought that they composed the inanimate world around them. And here he gave the pivotal role to plants, which made sense for someone who began his career as a botanist. Although, actually, I'm going to give you, before we get to botany, it's not quite right. He started off, actually, studying for the priesthood because his family, he came from a family of kind of impoverished military nobility, the 11th child of this family. And his family had drained their funds on the military careers of his older brothers. And so what did they do with him? When he was 11, they packed him off to the Jesuit seminary in Amiens, which is on the left of the slide. And he hated that. He didn't want to do that. When his father died, according to his son, Auguste told the story that when Lamarck's father died, his first words were, "So I won't be a priest," and he flung off the seminarian's collar and left the seminary. And what he wanted at that point was to be a soldier like his brothers, and so he managed to finagle a letter of introduction from a local countess whose brother was a high-placed general. And with this letter, he took one of his mother's old horses and galloped off to join this regiment that was fighting in Westphalia. This was in the midst of the 7 Years' War. And he arrived on the eve of the Battle of Vellinghausen, which, spoiler alert, the French were utterly routed. So great timing. But he managed to get himself taken into, so I've given you I don't have the Battle of Vellinghausen, but I gave you another approximate battle of the 7 Years' War. He managed to get himself taken into a regiment as a sub-lieutenant by the expedient of just marching off into battle with a company of grenadiers. And then when the captain and the lieutenant were both killed, he assumed command of the group. At least this is all according to his son Auguste, so maybe take it with a grain of salt, but it's a good story. And so that is how he came to botany. How's that for a plot twist? His regiment was then garrisoned in Provence. And he became enchanted by the flowers that blanket the Provençal landscape in a rainbow of colors. And during a leave at home in Picardy, he traded some of his precious music notebooks to his brother. He played the viola da gamba, and he had a lifelong love of music. But he was so interested in the flowers that he actually traded with his brother some music notebooks in exchange for a botanical handbook, Chaumel's Summary of the History of Common Plants, which is shown on the other side of the slide. And then when he went back to Provence, he brought that with him on rambles, collecting specimens and getting a local pharmacist to help him identify them. When he was 24, he left the military, and according to Georges Cuvier, who wrote, so Georges Cuvier, the paleontologist, and was Lamarck's arch nemesis and colleague, and he wrote the first official biographical essay about Lamarck in the form of what was supposed to be a eulogy, as in his position at the National Institute, he was supposed to write a eulogy, but it's the worst, most hostile eulogy you'll ever read. I'll read more on that in a moment. But anyway, he says that Lamarck left the military because one of his companions playfully attempted to lift him by the head, causing an injury to his neck, which, you know, if Lamarck's life were a novel, I think this neck stretching episode would be foreshadowing for the giraffe, his giraffe posterity. But It's possible that Cuvier actually used some poetic license because according to Auguste, Lamarck's son, the neck problem was actually scrofula, an illness. Anyway, he had to go to Paris in search of medical treatment. And once he got there, he started becoming a botanist in earnest, following courses in the Jardin du Roi, the Royal Botanical Garden. And one day he went on a botanizing jaunt with his brother and he on the outskirts of the city, and he encountered none other than Jean-Jacques Rousseau, who was out also on a field trip. Rousseau was then about 60, living in Paris, and in the thick of his botanical phase, he often went out collecting outside the city, and he condescended to do a field trip with Lamarck, collect together, as long as Rousseau was sort of famously neurotic and grouchy and impossible, and he said that it would be okay as long as Lamarck did not speak to him. He had to collect in silence. But even so, Lamarck was inspired by this, and he produced his first published work, which was a study of a 3-volume opus on French flora, in which he adopted elements of the Swedish botanist Carl Linnaeus's scheme of nomenclature, and also endorsed Linnaeus's idea that plants had sex, that is, that flowers were in fact sex organs, the stamens comparable to testes and the pistils to ovaries. Linnaeus was not the first person to say this. It was almost a century since the English doctor Nehemiah Grew had made that proposal, and various people had said this, but still it remained controversial, especially in France. But Lamarck boldly said not only that plants had sex, but that it distinguished them from minerals as organic beings. And he has these kind of rhapsodic passages about the sweet perfumes and laughing and lively demeanor of the flowers, and how for the self-centered human naturalist it seems to be all just for him, but in fact he's mistaken, because the flowers are not meant to beguile humans, they're meant to beguile other plants. So it's like this flirtation of the flowers. So this caught the notice of Georges Buffon, who was then director of the Jardin du Roi. There he is on the right side, kind of a giant in among naturalists, and a nexus of the world, the Enlightenment kind of scientific world. And he took Lamarck on as his protege. Around this time, Lamarck began developing his really radical idea that living things actually create the inanimate world, composing it from elements. He wrote that all minerals, by which he meant all inanimate compound matter, arose from the actions of living beings. And he thought plants played the primary role in this process because they could produce themselves just from sunlight, air, and water. And so he says a hyacinth or narcissus bulb suspended in a carafe of distilled water can grow an entire flowering plant. If you weigh the bulb and then you weigh the plant, you see that the plant weighs much more, so it has actually created matter, synthesized matter from elements. And he describes a similar experiment with using a turnip, where you carve an indentation in the side of the turnip, you hang it by its root, and you fill the indentation with water. And so it's sort of like Houdini, it's strung up there. It has nothing up its sleeves, nothing but sunlight, air, and water, and yet it creates a whole flowering plant. He talks about how he knows people who like to grow in the wintertime when it's dark and gray outside. They like to grow pea plants in earthenware dishes with just cotton wool and water. And I like to imagine at this point he was living with his wife Rosalie and 2 young children in a little apartment near the botanical garden. And I just like to imagine them in the dark gray Parisian winter watching decorative pea plants kind of conjure themselves out of thin air in the apartment. So this ability to merge elements, what he calls elements, into compounds, he says it's unique to plants. No animal can live just on pure water and earth and fire and air, sunlight and air. So plants originate this cosmic relay chain, bringing together the primitive elements and handing the combinations off to animals. Then the animals, by eating and digesting, turn plants or other animals into more elaborate compounds. And so they share with plants this defining ability of all living beings to build, compose, and create. So botany, he says at this point, is the most fundamental science because it studies plants, the original sources of all things on Earth, whether living or inanimate. Luckily for the history of biology, Lamarck was not allowed to remain a botanist, but had to remake himself at age 50 into a zoologist. During the Revolution, with the reorganization of the Jardin du Roi, they got rid of the roi, no more king, and they turned it into the Jardin des Plantes, the Republican just garden of plants. And the Revolutionary Committee in charge of this reorganization, and they created the Museum of Natural History, and the Revolutionary Committee in charge of this assigned Lamarck to the sort of lowliest of three positions in zoology, the professorship of insects and worms. So a middle-aged widower now with 6 children. Ultimately, he had 8 children over the course of 3 wives. Actually, only had children with 2 of the 3 wives. But he had little choice but to remake himself from a botanist to a zoologist. In order to assume this new professorship, he was entitled to lodgings in the garden, so he was able to house his family in an apartment on the 2nd floor of this 15th century mansion that Buffon had acquired to serve as the intendant's residence before the Revolution, and it housed staff. And I actually went in this past summer. It's not open, it's offices. It's like a warren of offices now, like little cubicles, and it's not open to the public, but I managed to go. I just stood outside with a friend and colleague, kind of looking hopeful, and somebody finally invited us in. And it was very cool to see, just sort of to walk up the stairs and look out through the windows into the garden and see what I'm sure it's very different, but still there are elements that are the same. So Lamarck later told his students that he had sort of been, had sort of thought, if I have to be a zoologist, he'd want to be a botanist, but if he has to be a zoologist, why couldn't he at least study big, exciting animals like lions and tigers, charismatic, what we now call charismatic megafauna. But then he realized that, he says, his assigned creatures were actually 9/10 of the known animal kingdom. I think more than 9/10, a lot more than that now. And he reasoned that the simplest animals must have come first in the order of nature's production. So he's already thinking in terms of an order of production. So in simpler animals, we might witness, he says, the essence and foundation of animal life. And contemplating his creatures, his insects and his worms with this gleam of hope, he divined an organizing principle and he renamed them invertebrates, inventing a new taxonomic category, the invertebrates. And he says the invertebrates conduct us insensibly toward the inconceivable limit of animalization, toward those beings barely endowed with animality, with whom nature perhaps began. This limit or minimum or essence of animality was, he says, the unbridled power of generation. They have this much more powerfully than more complex animals. The very simplest animals, such as polyps, have the most widespread generative faculty. The life of each of their parts is independent of all the others, so that you can chop them up. And this is what Tremblay, the Genevan naturalist, had famously shown with his experiments on the polyp or freshwater hydra, that you could chop them up in pieces and each piece will grow a whole new animal. So it's an extraordinary, and Lamarck points out that other invertebrates also have extraordinary powers of generation. The metamorphosis of insects, the generation of the head of a snail. Snails can regenerate their head. The legs of crustaceans, the rays of starfish. He says that because these animals have such extraordinary powers of generation and regeneration, the invertebrates greatly outnumber the vertebrates. Probably, he says, we'll never know their full extent because of the infinite smallness of the smallest among them. These tiniest and simplest animals, he says, display a frightening fecundity, such that it seems, so to speak, as if matter animalizes itself from every direction. But what must be our astonishment, he continues, upon learning that the tiniest and simplest of creatures, the madrepora and millipora coral polyps, with just a little help from shellfish, have been the chief producers of the great calcareous mountain chains and enormous banks of chalk found all over the earth. These minuscule animals create islands, fill up bays and gulfs, clog ports, and completely transform the coastlines. So he's imagining, right, a whole world, the surface of the earth, made by tiny living beings. And the invertebrates became the basis of Lamarck's theory that living organisms not only created and recreated themselves and the world around them, but he held a monopoly on creative agency. For my part, he says, without rejecting anything connected with religious belief, nor that it can be a consolation for the good man who persuades himself of it, I will say that this kind of consideration is absolutely foreign to my subject. So souls are not observable, physically knowable things, whereas the dynamic, creative action of living beings is everywhere you look, you see it. Life, to Lamarck, now became the manifest capacity to create in the face of all nature's forces of destruction. And the science of life was the study of this capacity for heroic creation. There reigns throughout the universe an astonishing activity, Lamarck wrote, living things doing the work of living, growing, reproducing, eating, digesting, propagating life among themselves. And to live is this constant work of construction and combination, merging elements into compound matter, in valiant defiance of the rest of nature's tendency to destroy all combinations. So there's a struggle. I mean, remember, right, this is the Romantic era, and there's this struggle of life against the forces, all the combined forces of nature. There's a note of tragedy in the story, since, of course, each living thing is doomed to ultimate failure. It will lose the astonishing principle that has allowed it to resist the onslaught of nature, continually dragging it toward its ruin. And then the vanquished being will be completely at the mercy of nature's destructive power. When living things died, Lamarck explained that they surrendered what they had made in their lifetime, their bodies and secretions and other productions, to the forces of nature, which then acted upon these, putting them through various transformations, producing minerals. Thus, on all sides, one perpetually sees nothing but an alternating succession of life and death, formation and destruction, movement and rest. So Lamarck's idea of living beings as tragic heroes striving to create as much of the world as possible before surrendering to their fate may sound like a romantic notion, capital R, as indeed it was. Yet 2 centuries later, the role of organisms in the formation of minerals has inspired renewed interest among geologists. And maybe, I don't know, I'm suddenly aware that I may be talking to people who know much more about this than I do, but I've borrowed this slide from a geologist, Robert Hazen. So the images on this slide illustrate the great oxidation event, a sharp increase in atmospheric oxygen that apparently took place a little over 2 billion years ago, in which emerging microorganisms seeded the air with oxygen. And this was apparently probably the crucial turning point in the proliferation of diverse minerals on Earth, as Robert Hazen, the mineral physicist whose images I've borrowed, has put it. The origin of life depends on minerals, but the origin of minerals depends on life. So Lamarck's theory of living beings was also a theory of the composition of matter, and it angered the authors of a competing theory of the composition of matter. In fact, when he tried to read a work presenting his theory at the National Institute, he was interrupted and kind of criticized and sort of heckled so much that he finally abandoned it. And his ideas were especially offensive to 3 influential people who would soon become favorites of Napoleon. One, on the left side, it was a mathematician, astronomer, physicist, and statesman Laplace, Pierre-Simon Laplace, whom Napoleon appointed Minister of the Interior and then ennobled as a Count of the Empire. Another was the doctor and chemist Antoine François Fourcroy, whom, in the middle, whom Napoleon would appoint to his state council and make him Director of Public Instruction, and also ennoble as a Count of the Empire. So these were kind of Napoleon's inner circle of scientists, of science advisors. And I'll get to the third one later. But Laplace and Fourcroy had each worked closely with Antoine Lavoisier, who was a chemist and tax collector and philosophical revisionist, who had lost his head to the guillotine in the spring of 1794, along with the other tax collectors. But his approach to chemistry remained very much alive. So I'm going to make a little detour about Lavoisier now. He and his comrades had set out to do no less than remake the general understanding of the nature of matter. They announced a long list of elements to which they said, so get rid of the earth, air, fire, and water, Aristotle's, the ancient theory of matter. And in place of that, they have this long list of things to which they say all kinds of matter can be reduced, and these can be solids, liquids, or airs, depending on how much caloric or heat they contain. This claim went along with startling experimental results. Water, for instance, Lavoisier announced, was made from 2 different kinds of air, one highly flammable, the other one excellent for breathing. And the chemical, so that's on the, let's see, the experiments on respiration on the left demonstrating the equivalence of respiration and combustion, and on the right is the analysis and synthesis of water. So they demonstrated the composition of water and other substances in a series of decomposition and recomposition experiments using a very precise balance to weigh the ingredients and the products of each reaction. They assumed that matter was conserved, and so the combined weights of the ingredients should equal the weights of the products. And they identified the lightest products that they could make as the simplest units of composed substances, and they said these are the true elements of matter, to which they gave these Greek names, oxygen and hydrogen and so on. So reduction was Lavoisier's and his collaborators' chief experimental procedure. In experiments, they reduced various kinds of matter to the lightest possible parts. Reduction was the defining feature of their worldview. They saw the material world as reducible to these invisibly tiny elements, inert elements. And reduction, finally, was the central principle of their model of science. To them, explaining something scientifically meant breaking it down into its smallest parts. Lamarck attacked these chemists, including Laplace and Fourcroy, the first two who had both collaborated with Lavoisier. In a series of writings in the mid-1790s, he attacked them, culminating in the memoirs that when he tried to read them at the Institute, he was heckled and he had to give up. And generations of historians have sort of shaken their heads in rueful mystification about why Lamarck, who had been a botanist and was now a zoologist, would pick a fight with these chemists, like why? But it wasn't actually gratuitous. He had a reason connected with his new science of life that he would soon name biology, which is that he was defending the creative agency and irreducibility of living things, which the new chemists denied. So, for instance, Fourcroy wrote that nature merely lent materials to plants and animals for a brief time and then took them back to go on executing her perpetual cycle of composition and decomposition. Lamarck retorted that nature can't compose anything, only living beings can compose. So against the new chemists' mechanical theory of composition by heat and pressure, Lamarck presented an entirely different theory of the composition of matter based on the agency of living beings and the principle that they were the unique force of composition. The entire surface of the globe, he wrote kind of dramatically, the bosom of the waters and the whole atmosphere are the vast field where nature ceaselessly destroys every composed substance which the principles of life does not defend or ceases to maintain. At the same time, against the new chemists' reductive model of scientific explanation, analyzing all things, including plants and animals, into their lightest parts, Lamarck developed a very different kind of explanation. He argued that living organisms and the things they composed were not, he said, susceptible to analysis. They're irreducible. No analysis could break them down into their component parts because he said they had no pre-existing component parts. They synthesized themselves and the world around them just from elements. So what Fourcroy was taking for the constituents of organic matter were in fact the products of organic action, according to Lamarck. They were not the constituents, they were the products. Therefore, instead of reducing everything to immediate principles, Lamarck concluded, let's simply say that vegetable and animal matters are the products of organic action characterized by distinctive, remarkable properties. So posterity has judged Lamarck to have been just wrong in rejecting the new chemistry, which is the basis of our modern understanding of matter, and Laplace and Fourcroy to have been right. In a sense, that's true. They came up with a very powerful understanding of the nature of matter that became the basis of modern chemistry and physics. But you can see it in a different way, as there's a sense in which it's not so much a matter of right versus wrong, but different ways of seeing things, competing ways of seeing things. If we define elements as the lightest parts of matter producible in laboratory experiments, then of course it makes sense to say that hydrogen and oxygen are the elements that make up water. But if we define the elements of matter as the primitive substances out of which living beings compose themselves and the world around them, then maybe it makes sense to say that these elements are sunlight, air, and water. And it might even, according to this way of looking at things, it might even make sense to say that oxygen is not an element, but a product of organic action, if indeed its presence in Earth's atmosphere results from the activities of living beings. It's a way of seeing it, perhaps. Historically speaking, of course, Laplace's and Fourcroy's way of defining elements triumphed, along with their reductive definition of science. And in the wake of their success, Lamarck's vision of nature, of science, and of life became not just wrong, but really kind of unthinkable, beyond the pale of legitimate science. I haven't gotten to that yet. Okay, so another member of Lamarck's inner circle, of Napoleon's inner circle, whom Lamarck antagonized, was the Lutheran naturalist Georges Cuvier, who I mentioned earlier, who occupied the chair in comparative anatomy at the garden, at the Botanical Garden in the Natural History Museum, and whom Napoleon also appointed to ever higher administrative posts. Cuvier rejected the idea of that living forms changed from generation to generation. He believed in the fixity of species. His central anatomical principle was the principle of correlation of parts, which is basically a principle of rational design. He said you could infer all the parts of a creature from any single part because they all followed from one another by rational necessity. So he was very brilliant comparative anatomist, and people were excavating extinct creatures, and you could bring him a metatarsal, and he would say, okay, the rest of here's what you should now look for next, and people would go looking for these fossils and finding them. He did believe in extinctions, but he took the fossils of extinct creatures to reflect not change over time, but catastrophes like floods and fires that eliminated all the creatures at a given time and place to be replaced by brand new, equally fixed and unchanging creatures later. So all of this implicitly supports the doctrine of special creation, that God had created each species for its niche in nature and replenished the supply of creatures following each catastrophe, such as the Great Flood in the Bible, by new acts of creation. And the principle of correlation of parts reflects also the rational design of the designer of these beings. All of this could hardly have been better suited to Napoleon's purpose. Here was a scientific doctrine of revolutionary change that was at the same time profoundly conservative, each revolution imposed from outside rather than rising up from within, each a return to the same ultimate authority, the whole thing guaranteed not by the church but by Napoleon's savant, his circle. Cuvier's science, in other words, was cutting edge, but at the same time it bolstered rather than threatening an authoritarian order. First Napoleon's, and then under the Bourbon Restoration, Charles X would make him a baron. It was emphatically not the science of the materialist atheist revolutionaries from whom Napoleon was trying to distinguish himself in order to gain the royalist ground, but it also wasn't the science of the older Catholic Church. It was this kind of perfect combination of, Cuvier basically translated the authority of religion into science and produced this very powerful modern combination. So it's probably not surprising that Napoleon really hated Lamarck and his advisors hated Lamarck. And the image on the slide illustrates a famous story first told by the astronomer François Arago, which took place when he was just 23 years old. Arago was just 23 years old. On a chilly day in December 1809, the members of the National Institute were waiting for the emperor in a cold, frigid salon of the Tuileries Palace to present him their new publications, as was traditional. And standing near young Arago was Lamarck, now 65 and in poor health, although he would live another 2 decades, but he was frail. He held a copy of his Philosophie zoologique, which was published just that year, his magnum opus in which he describes living beings as transforming themselves infinitesimally but incrementally over generations. And Arago and Lamarck were noticing as they waited how everybody was sort of so nervous, that hoping to catch the emperor's attention. Napoleon at last entered the room and marched up to Arago as he would to a new conscript, fixing him with a stare and barking, "You're very young, what's your name?" Before Arago could answer, his neighbor on the left, wanting to be noticed, said, "He's an astronomer." Napoleon, "And what have you done?" Arago's neighbor on the right, not to be outdone, says, "He has just been measuring the meridian in Spain." While Arago was ruefully reflecting that Napoleon must take him either for a mute or an imbecile, the emperor turned to Lamarck, who presented his Philosophie zoologique. Napoleon snatched it from him, growling, "I take this only out of consideration for your white hairs. Give it here." And without looking at the book, he thrust it into the hands of an aide, while Lamarck, tears of humiliation rolling down his cheeks, tried to explain what was in it. Had Napoleon known what was in that book, I mean, he knew something about Lamarck already, but had he known the full story, he probably would have liked it even less, because Lamarck's natural world of inherent active powers, its substance literally generated and shaped by its own living denizens, was uncongenial to authoritarians. Cuvier was the victor who wrote the history quite literally. As I've mentioned, he wrote Lamarck's official eulogy, in which he said that Lamarck's science was really poetry, and nobody had found it interesting enough to combat. It wasn't worth combating, it's just poetry. And that condemnation set the dominant tone for assessments of Lamarck's ideas for a long time to come. Now, I'm wondering how much time I can talk about. I can sort of follow the story up, give a kind of sketch of the story through the 19th and 20th centuries, but maybe we don't have time for that. Shall I skip that? Okay, we have time. So the fact that Lamarck's theory located evolutionary agency within the evolving organism, emerging as it did from Enlightenment French materialism, coming into print immediately, during and immediately following the French Revolution, made Lamarck's approach smell to contemporaries of atheism, Jacobinism, radicalism, regicide, very dangerous, bad stuff. All of these ill odors promise trouble, not only for Lamarck and Lamarckism, but for evolutionary theory more generally. And so Charles Darwin struggled over his relations both to Lamarck and to his own grandfather, Erasmus Darwin, who's on the left side, who had been a doctor, naturalist, poet, another romantic poet, and great admirer of the revolutionaries in France, Francophile, and admirer of the revolutionaries, for whom he'd written some verses. And Erasmus Darwin had also described living organisms as transforming from generation to generation, sometimes in verse. Charles Darwin drew both upon Erasmus Darwin's ideas and Lamarck's ideas, but he was sometimes torn between, or I think in general, he was torn between admiration for these precursors and embarrassment about them. And sometimes he referred to their theories very scathingly. So on the right side is a page from Darwin's Notebook B, his 1837 notebook, in which he's starting to think about transformism, and jotting things down and crossing them out. And so wrestling with his grandfather, Erasmus Darwin's, and Lamarck's ideas. And the crossed out line says, man is derived from monad, each fresh, and then it breaks off, and he scratches it out. And monad was Lamarck's word for the simplest spontaneously generated living organisms. But Darwin did retain various forms of agency within the evolving organism, including what he called the inherited effects of use and disuse of limbs and organism. We were talking about that a little bit before the lecture. That's in every edition of The Origin of Species up through the 6th edition in 1872, which was the last in Darwin's lifetime. And it's in every major work that in The Descent of Man, on variation in plants and animals. Darwin never questioned that. The inherited effects of use and disuse are what came to be referred to as the inheritance of acquired characteristics. It was really his followers in the period after his death, around the turn of the 20th century, especially in Germany and America, who went about eradicating all traces of Lamarckism, use and disuse, in their reinterpretation of the theory. So the German evolutionary theorist August Weismann, in particular, offered interpretations of both Lamarckism and Darwinism that became standard in the 20th century. The Darwinism of Weismann's redefinition eliminated both of Lamarck's internal agencies, the complexifying force of life, and the role of responsiveness, habit, and will. Weismann located evolutionary agency emphatically outside the organism. He said no kind of experience or behavior on the part of individual organisms could ever change the machinery of inheritance. He posited an unbreachable barrier separating somatic body cells from germ cells or reproductive cells, and he said that no changes taking place in the somatic cells could ever be transmitted to the germ cells. This was the so-called Weismann barrier, eliminating the possibility of inheritance of acquired characteristics. The emblem of Weismann's theory was an experiment in which he chopped the tails off several generations of mice in order to show that their offspring had perfectly healthy tails. Now, Weismann himself acknowledged that this experiment had no real bearing on Lamarck's theory, since it tested neither an intrinsic complexifying force of life nor the transforming effects of responsiveness or habit or will. Neither Lamarck nor Darwin had said that amputations were inherited. But he said it would defeat the popular version of belief in inheritance of acquired characteristics. And so it did. I mean, it was very, very powerfully catchy. So the slides are, recent images from online biology textbooks. Still, I think to this day, people cite Weismann as disproof. The Weismann barrier separating somatic cells from germ cells was, in fact, a barrier separating individual agency from evolutionary transformation. And it remained that, a denial of evolutionary agency to organisms, when it became a core principle of neo-Darwinism. For instance, when Francis Crick stated it as the central dogma of molecular biology. I've always found it interesting that he calls it a dogma, because usually to say something is dogmatic is not a recommendation, but he certainly meant, he meant it. Anyway, right, the idea that there's no reverse, that transcription only goes in one direction from DNA to RNA to protein and can never go from protein to RNA to DNA is basically a restatement of the Weismann barrier. And so Weismann erected a lasting barrier between individual agency and evolutionary transformation. His doing so reflected the culture of the emerging German research universities. Weismann taught at Freiburg, in which, this is a moment in which the universities in Germany were transforming from medieval theological seminaries to juggernauts of modern scientific research, and their science and theology faculties worked out a kind of limited partnership arrangement in which the science faculties restricted themselves to very, very specialized technical, mechanical, sort of demonstrations of the mechanical complexity of natural forms, but in a sense it was fundamentally a passive mechanism, leaving a monopoly on questions of meaning and will and agency to the theology faculties. So it was a kind of institutional application of the argument from design, which had banished agency to the province of a supernatural God, leaving behind a mechanical world that was infinitely intricate but fundamentally passive. And in fact, Weismann himself emphasized that his mechanistic approach to biology, rendering living beings as passive machines, was predicated on the assumption of a divine presence beyond the universe and responsible for that. Weismannism came to dominate biological thinking in the United States in the early to middle decades of the 20th century, crucially transmitted by someone who came up within the same world of the German research university, Ernst Mayr. Mayr studied biology at the University of Berlin in the mid-1920s, and his advisor was the ornithologist Erwin Stresemann, who greatly admired Weismann for having vanquished Lamarckism. Stresemann was a believer in the passive mechanist view of living forms. For example, he wrote, "An animal does not act for itself, but under a higher commission." And he even puts it in Latin, animal non agit sed agitur, does not act but is acted upon. And he also subscribed to the view that the animal does not think, does not reflect, does not establish aims for itself, and if it nevertheless behaves purposively, then someone must have thought for it. So notice how both of those expressions, the passivity of the mechanism of the organism directly implies a someone, capital S, a higher power. When Mayr went to New York in 1931, he, of course, brought along his training and influences. By then, at any rate, the United States had been importing the German model of the research university with its institutional culture and practices, particularly in biology, for more than half a century since the founding of Johns Hopkins in 1876 on the template of the University of Berlin. American biology was a well-prepared soil into which to plant Weismann's ideas and the model of science that they represented. And this Weismannian interpretation of Darwin and repudiation of Lamarck thrived here and elsewhere, remaining strong throughout the 20th century. Just as an example of this, consider Daniel Dennett's 1995 book, Darwin's Dangerous Idea, by Daniel Dennett. And he and Dennett and Richard Dawkins both describe themselves as Weismannians, and they certainly have devoted a lot of ink to making biology safe from Lamarckism. So on the slide are some passages where they refer to Lamarckism as painful, scary, fatal, devastating. It's a lot of heat. And I think to understand where all that heat comes from, you need to know the long history of this struggle in which people saw Lamarckism as a threat, not just to a particular scientific idea or theory, but to a whole worldview, to modern science itself, founded as it was on this originally theological principle of rational design that dictated that science be the reductive account of a fundamentally passive mechanical artifact world. The irony is that, Ernst Mayr was not religious. Richard Dawkins certainly isn't. So I think there's an ironic sort of passage of this model, transformation of this model, in which I think the heirs to the argument from design no longer realize where their model originated. Just as a postscript, I want to refer to the fact that Lamarckian principles, by which I mean sort of the idea of some evolutionary agency on the part of organisms, have been making their way back into mainstream biology. I think perhaps in the study of epigenetic inheritance and factors affecting gene expression, which is a big and growing area of research. That constitutes a departure from neo-Darwinism, since it includes the inheritance of characteristics acquired, or the possibility anyway, of inheritance of characteristics acquired in an individual lifetime. These are examples on the slide of recent proposals that epigenetic inheritance might play a role in Lamarck's kind of paradigm case of the giraffe's long neck, one by Floyd Reed, a population geneticist at the University of Hawaii, and one from two biologists, Rosalind John at Cardiff University and Claire Ruguel at Paris Diderot and the CNRS. I'm actually now involved, I was mentioning to some people before, I'm involved in an experiment with Floyd Reed and my colleague Mark Feldman at Stanford and Mike Skinner at Washington State on just a very, very preliminary experiment to see about the possibility of epigenetic structures in giraffes, in giraffe inheritance. It's sort of irresistible. But that's all. Epigenetic inheritance is, of course, by no means the only area in current biology that threatens the neo-Darwinian insistence on the evolutionary passivity of the evolving organism. I think a growing number of biologists have been working to incorporate developmental and ecological and behavioral and even cultural factors into evolutionary theory. And when I was at Yale last week, I met a young woman researcher there named Martha Munoz, who's doing this extraordinary work with lizards that have, migrated from sea level up to 3,000 meters in the mountains, and where it's much, much colder. And she has been studying the way in which they have, she says they've been behaviorally nimble. They've found ways to warm themselves in the crevices of the rock. And so they have not evolved cold tolerance, but instead they have evolved phenotypic features that make it easier to hide in the crevices, like flatter heads and shorter legs and things. And so she sees this as a way in which behavior leads natural selection. So that's a whole other area that I think is really interesting. Napoleon, I think, would be annoyed, but that's a story for another day. Thank you very much. Thanks.
Thank you, Jessica. That was awesome. Great. So there is time for questions, and because this is being shown both on Zoom and recorded for later observation, please ask your questions into the microphone. And we have maybe two people. We have two people coming around. So here's a question right over here.
Thank you for your talk. It was fascinating. I remember hearing sometime in either high school or college that Lamarck had been discredited, of course, in United States scientific circles, but I remember hearing that in the Soviet Union, they were fans of Lamarck, and of course that was why they weren't advancing scientifically like we were, was what I had heard during the Cold War era. And I wonder if you could comment about whether the Soviet scientists were embracing Lamarck and why.
Yeah, thank you for that. So I have a short chapter in the book. Oh, I should talk into this, right? I have a short chapter in the book manuscript about Lysenko, who did indeed describe his theory of how to change the germination of wheat, the vernalization of wheat. To change it from winter to spring. He described it as Lamarckian. He said basically that you could subject wheat to these conditions, cold and wet, and change the germination season, which already farmers did. I mean, that was a practice that farmers used. But he then also said that it would be inherited in the next generation, which it isn't. And he described this as Lamarckian. And this became Lysenkoism, sort of with Lamarck's name kind of attached to it, became Stalin endorsed it, and it became the kind of official doctrine. But the thing about that, though, is that it isn't very Lamarckian. It doesn't involve, it's a change that's imposed from outside brusquely. It's more like an amputation, it seems to me. And the other thing that's really interesting about this episode is that, so Lysenko made a fraudulent claim, but the response to that in the United States was very ideological anyway, right? So people like Julian Huxley, kind of neo-Darwinists in the United States, fastened onto that as a way of insisting on their model of evolutionary biology and the kind of eradication of Lamarckism from evolutionary biology. And it became, as you said, it became a kind of, it was very ideological in the Soviet Union. It became very difficult to do genetics research. Symmetrically in the United States, it became very difficult to do research in evolutionary biology that looked beyond just random genetic variation and natural selection. So the fact that Lysenko made a fraudulent claim doesn't mean that the reaction to it was not deeply ideological. Now, I was just talking with where's Jenny? Yeah, we were just talking about this before. Do you want to add anything to that? Because you know all about that, right? You're writing about that. Yeah.
I will pass at this point to make further comment.
Sorry,
but I do think it's an incredibly important part of the story of Lysenkoism. But I think the point you're making about whether or not Lysenkoism is really Lamarckianism is also interesting.
And also, I will just say that I think it was also, there was some opportunism involved in that, right? That Lysenko was taking this kind of anathema of bourgeois capitalist science and invoking it, right? Because Lamarck was already in ill odor. So, yeah, that was a kind of obvious, on some level, obvious thing for him to do. Yeah.
Thank you for that talk. So given that Lamarck didn't know anything about epigenetics,
Right.
did he propose any mechanism for the inheritance of acquired characteristics? You mentioned briefly external to internal.
Yeah, he didn't, so he did describe a mechanism, but it's a very hand-wavy, impressionistic sort of, he says fluids, for Lamarck it's all about fluids. So, when for example, the way that habits transform the body is that when the will causes the animal to act in a certain way, then the bodily fluids flow to the part of the body that is needed, right, to strengthen it and build it up. And then, somehow that strengthening and building up is inherited in the next generation. So he doesn't really have a very satisfactory, he's just sort of describing the way he thinks it might happen. Now, Darwin had a theory of inheritance, pangenesis, in which he said that there are these tiny little particles that he called gemmules, perhaps. He presents this as very, very hypothetical, right? And tentative. But he says that perhaps every part of the body is giving off these tiny little particles called gemmules that collect in the reproductive organs, and they carry inherited traits, including the inherited effects of use and disuse. And so all of his idea about pangenesis, then there's a kind of lineage from that through subsequent theories of atoms of inheritance or particles of inheritance that ultimately lead to genes. But there's an important difference between genes and Darwin's gemmules, which is that the gemmules do carry the inherited effects of use and disuse. Yeah.
Bringing us back to the giraffe.
Yeah.
If we're going to evoke several different generations through which the neck gets longer, why do we need to invoke epigenetics? We can have genetic mechanisms by which that occurs.
Tell me, not being a biologist, I would be glad. You mean, so maybe something like what I was describing with Martha Munoz's lizards?
Exactly.
Yeah, so it would be like a behavior leading natural selection.
I'm not saying that it's not epigenetics, but I'm saying you don't need to invoke
You don't
that.
need to be, yeah, maybe. Thank you.
Thank you. That was a wonderful talk, and thank you very much. I read the book The Light Eaters by Zoe Schellinger, and she actually talks about Lamarck and also all the research that is being done in regards to habitat impacts and chemistry, light, And I would like to hear your take on her book, on her perception, and all the other scientists globally who are finding out incredible new ways of, yeah.
Yeah, I'm not sure I can, I know the book, and I think it's a fascinating book, but I'm not sure, what do you mean by take it on? I will say, do you mean talking about the kind of ecological dimension of Lamarck's ideas?
Yeah. From the little that I have read about him, he actually, thank you. He actually, his concept, ideas, and observations really back up what is being researched now,
Yeah.
proven to be right.
Yeah.
So it's like, yeah, his
you
stuff
for
is
that.
boots on the ground, and
Thank you for that. Yeah, he has a couple of interesting passages in his writing that are kind of, that, especially today, kind of resonate. One is when he's talking about extinctions. So he was always at loggerheads with Cuvier, and Cuvier said that the fossils that we find that don't correspond with anything living on Earth today, it's because there were these extinctions like I described, like the flood, Great Flood in the Bible. Lamarck said, no, it's because things have changed over time. So on the whole, he didn't really believe in big extinctions. He thought that living beings have transformed over time, and that's why the fossils don't correspond. But he made one exception to that, which is that he said, except for human beings have wiped out, surely have wiped out all kinds of, have rendered all kinds of beings extinct. So he described human evolution also. He was, before Darwin, we associate with Darwin the idea that humans have evolved from other primates, but Lamarck said that. In fact, Darwin credited that idea to Lamarck, and Lamarck describes that process. It's not at all a beautiful process. The way he describes it, certain primates began to, came down from the trees and began to walk upright and were tremendously violent and rendered the lives of their fellow primates miserable by driving them to the corners of the earth and rendering extinct. So that's one kind of set of passages where, and then another one is at the very end of his life, he wrote quite a despairing, because he lived through the industrial, he lived through the Industrial Revolution, and he at one point got sent by Buffon to visit mines and sort of study industries of Central Europe, and also had witnessed warfare. And so he writes this very despairing passage in his last work that he dictated to his daughter after he had gone blind. And he basically, he says in this passage, he talks about deforestation and the terribly destructive effects of war and industry. And he says, it seems that humans are going to render the planet uninhabitable. So, yeah, there are a couple of passages like that.
Hi. Yeah, thank you very much. The talk was fascinating and the discussion is great. And I couldn't help but notice that there was kind of this shadow of authoritarianism over your talk. And then we end with the grumpy Napoleon. And I just wanted to invite you, if you wanted to elaborate on that a little bit more and the relationship between politics and scientific development.
Yeah, so I do want to, although it's always sort of risky to make, I run the risk of making connections that are too neat, but it does seem to me that a theory of kind of intrinsic agency of living beings is one that lends itself less well to various theories of authoritarian control than theories that involve the consolidation of power in a single, force, like Cuvier's, and so. And it is the case. I mean, I kind of ransacked Lamarck's writing to see what he had to say about race and sex, human sexes, human races, social classes. All around him, people were constructing biological theories of race. I mean, everybody around him was doing that. The extraordinary thing is that he seems to have had essentially nothing to say about this. He didn't do it. And so for example, he wrote a great deal about female invertebrates, but he didn't, many people around him were kind of drawing lessons from females of other creatures to talk about, the intrinsic properties of human women and coming up with biologically kind of determinist theories of race. And he didn't do that. Now, it's not to say that he couldn't, there were later on Lamarckian eugenicists, especially in the United States. It's not that one couldn't. I think one can put any theory to any political use. So I don't want to say that there's that kind of tight connection. But I do think that, Lamarckian eugenics in France, for example, in the later 19th and 20th century, there were Lamarckian eugenicists in France whose idea was that if you improve nutrition and hygiene and education for poor people, the effects of that will be inherited in the next generation. So their project was kind of public health, and so that's sort of a more benevolent form of eugenics in that instance. It's not always the case. So yeah, I think it seems to me that a theory of intrinsic agencies of living beings tends in a better direction with respect to authoritarianism. Yeah, that's what I think. What's that?
Oh, okay. Oh, you had.
Yeah, I'll go. Thank you. Especially with him being a professor of insects, as I read that and listened to you, it brought to me the idea of scale on this, as well as agency and individual intent versus group. Because we certainly see that, in a sense, he's very right about life having transformed the planet. And the way in which life has created organic matter and changed its environment, that then creates a change in natural selection because you're changing the environment which things are succeeding. Yeah. But in particular, in the question of scale, we have the individual organism, but the idea of more of a superorganism, and it reminded me of E.O. Wilson's work, and sort of looking at the intelligence of a colony, and how, as a superorganism, it creates a change in its own environment, and the environment the superorganism creates, and the degree of agency that superorganism has, selects for the component individuals within it, which succeed within that. So even if the individual components of it don't have the ability to have intent or as much agency, the broader organism, including, say a mammal, you've got the cells which exist within us, how those adapt because of what the superorganism is, its own agency and intent in that, and how that relates to Lamarck.
It's interesting. I mean, it seems to me like there's a kind of maybe symmetry between Dawkins' selfish gene and Wilson's superorganism, which is it's a removal of agency either lower or higher than the individual being. And somehow, to me, that seems to me consistent with a kind of, well, and in Dawkins, I think also in Wilson, but certainly Dawkins is explicit about that, that he's a Weissmannian, he doesn't believe in, he believes that the organism is passive, but the gene is active. So what am I trying to say? I'm trying to say that those removals of agency either to a higher level or a lower level seem to me like another way of denying agency to the individual being, living being, the individual organism in interacting with other individuals and with the natural environment. So Lamarck, I mean, I think he's very interested in this kind of interconnected handing off. Plants compose elements into compound matter, and they hand off to animals, which hand off among themselves to one another, and they're creating the inanimate environment around them. So there is a kind of interconnectedness. But I don't see any equivalent of a superorganism, I don't think, in Lamarck. Now, interestingly, though, I mean, this is a period in which you started with insects and Wilson, so it's a period, of course, even earlier in the 18th century. I'm thinking of Diderot's discussion of bees in D'Alembert's Dream, but there are lots of instances of this in 18th century writing, in the earlier Mandeville, interest in kind of the insects as a model of what you're describing as a superorganism. So it's interesting, actually. I'm not thinking of examples from Lamarck, but certainly around him, people were interested in that kind of phenomenon. Yeah, so it could be in Lamarck. I will look harder.
So, I guess I have the microphone now. Yeah. So my question, going back to the Lysenkoism point, but also asking Zach's question in a slightly different way. A question that I have is that I don't know the answer to, maybe you do, is what were the reading practices of Lamarck? I mean, so how were people reading Lamarck? How did Lysenko come to read Lamarck? Was Lamarck being read, and how is it being read, right? And then I guess I would also be interested to hear, to what extent are you looking at Lamarck, and how would you make, what's the difference between Lamarck and Lamarckianism? And so getting to, you're talking about Crick having, the central dogma, and we talk about Darwinism and Lamarckianism. To what extent is Lamarck as a figure distinct, you've got Lamarck that you're studying, and then there's Lamarckianism, and that gets to the reading practices of Lamarck, or the meaning that's made of Lamarck over time. And so I'm interested in, to what extent are you interested in the latter? And what do you know about the reading practices of Lamarck in that long period?
Do you mean people reading him, not him reading? Right?
Yeah.
I do actually have an inventory of every book in his library, because there was at one point an inventory of his whole apartment, so I know the books that he owned.
Not what he was reading.
You mean other people reading him.
I mean, because I'm really interested in how did Lysenko come to be Lamarckian?
Right.
So was he reading Lamarck, or was he reading something else? And then it gets, because your comment about Lamarckian comes to have a kind of meaning, as it's tarnished, right? So. Okay,
so I think, of course, that's much later. I mean, that's, in the mid-20th, early to mid-20th century. So it's much, much later. But I think that, well, the first thing is that Lamarck produced an enormous, very important compilation of invertebrates, multi-volume work, which he put in the beginning of that a kind of restatement of the theory from the Philosophie zoologique. And that was a very clever move, because people all over, wanted and needed this compilation of invertebrates, and then they got along with it as a package deal. In the front, the first part of that was Lamarck's theory. So I think, there was that. I think also Darwin owned works by Lamarck and wrote about them, pretty extensively in his writings. So that was another kind of promulgation. Actually, even before that, Vestiges of the Natural History of Creation was a kind of runaway bestseller in England, published anonymously. It was by Robert Chambers, but only posthumously. That was only posthumously revealed, and there was this kind of, everybody was trying to figure out who had written it, and there were many theories, and so that was a very sensational kind of Lamarckian. It is a Lamarckian theory that he presents in that. He kind of hedges a little bit, because he knows that Lamarck is a bad word, so he tries to distinguish himself from Lamarck, but basically he is offering a Lamarckian theory in that. And so that was a further promulgation before Darwin. Then you have Darwin. And then I think at the end of around the turn of the 20th century, there's this moment with William Bateson riding on a train and reading Mendel's article and having this epiphany, and from there, I think the kind of emerging science of genetics is very much about eradicating Lamarckian, partly anyway. I don't want to say only about that, but it's an important element, the kind of elimination of Lamarck. And so by the time you get to the mid-20th century in Lysenko, I think there's this drama that's been unfolding all this time. And so I think that's partly why, as I say, I think Lysenko, there was a kind of obviousness to it for him to seize hold of this kind of persona non grata of bourgeois capitalist science, which is what Lamarck had certainly become by then.
Thanks. A wonderful talk, really enjoyable, and especially for me enjoyable because I encountered the names of all those streets in the 5th arrondissement that I used to frequent as a graduate student in Paris. But my naive question is really just about worms. Darwin wrote a whole book about worms as a world-making critters, and there's no. I'm thinking about the worm as the sort of structural opposition to the giraffe, in a sense. Did Lamarck write about worms? Were they heroes in his pantheon?
He did write about, the thing is that what worms meant, initially, worms, he had these two kind of vast categories of insects and worms, and the worms included mollusks and, all kinds. So he gradually sort of refined the categorization. And in fact, he also distinguished between internal worms, parasitic worms, and external worms. That was a distinction that Cuvier also was working on. But Lamarck said that external worms actually weren't worms. He renamed them annelids. He coined the word annelid for earthworms. And that became an important moment in his charts. He was drawing these charts of descendants of different forms of life. And, he kind of separated the developments that come from internal parasitic worms from the annelids. So this is a long answer just to say that he was very much interested in worms. But Darwin's last work was this work on earthworms. Right. It's a beautiful, it sounds like you know it well. It's a beautiful text, but one of the things I think that's beautiful about it is that Darwin remained throughout his life really interested in what he called small agencies, right? The way in which earthworms were intelligent. He collected observations that people made in their back garden of the way that earthworms would suit this shape of a leaf to the hole in the burrow that they were blocking, and he was interested in the intelligence and agency of earthworms. And he says they've also shaped the English countryside. When you look across the beautiful agricultural English countryside, it's all thanks to earthworms. So. Right.
Well, yeah.
So two more, and maybe we should draw to a close. But there are two more back.
Thanks for a terrific talk. I really enjoyed it. My question is whether, sex and sexual selection sort of throw a wrench in both the passive view of neo-Darwinian evolution, and it's also not exactly sort of evolution through use and disuse, but it's this odd thing where you say, well, I'm going to evolve by acquiring your characteristics, right? And so I wonder what Lamarck's understanding of sexual selection was, and any other thoughts you have on that.
I'm so glad you asked that. Although I don't think Lamarck, as far as I can think of, but again, I'll look again, I don't think he addresses it. But what I'm really interested in Darwin on sexual selection, because Darwin basically, it's totally fascinating, Darwin's idea of sexual selection, basically that animals choose mates that are attractive to them, and he says by their own standards of taste and beauty. And so they are kind of creating one another and their offspring and so on according to their standards of taste and beauty, and it's separate from natural selection. Darwin offers this as a really a completely separate thing, and he then applies that to his understanding of human races. So he says that human races, the differences among human races he thinks they're real differences. He describes them, but he says they are too shallow. They are inert with respect to natural selection. Natural selection can't have anything to do with these differences. They're too shallow. So they must have come about as a result of sexual selection, basically the different standards of taste of men in different parts of the world. Now, it's interesting that with birds, he says it's the females that do the choosing, but in humans, he thinks it's the men. I don't know, I find that interesting on many levels, that he thinks that it's basically culture, animal cultures that create animal forms, and human culture that creates human diversity. So I think that is pretty fascinating, actually. Oh, and one more thing I'll just add, because you said that it throws a wrench in natural selection. So as I understand it, but probably biologists here can talk about this better than I can, I think that there is a debate among evolutionary biologists whether sexual selection reduces to natural selection. That is, so a female peacock would choose a male peacock with an extraordinary tail because clearly this guy has, calories to burn, so he must be super fit. So it just reduces to fitness. It sounds to me like a really silly argument, but I think that that is an argument that that sort of hardcore neo-Darwinist selectionists make.
Yeah, I guess what I was getting at is that there's clearly agency in sexual selection, so that you could make an argument that it's passive, as you just said, or you could say, oh, well, I'm going to choose these characteristics which are apparent in my mate for my progeny, which clearly has a lot of agency in it. Anyway, yeah, thank you for that.
Yeah, first, thanks for an amazing talk. You mentioned the stream of epigenetic research that reintroduces notions of the agency, the internal agency of living beings. And you mentioned the form follows function, or behaviors shape the conditions of selection. But there's a whole other third stream that maybe has some relationality to Lamarckian thinking too, or not. I'm thinking of Lynn Margulis and autopoiesis and first and second order cybernetics and Maturana and Varela. Not so much Lovelock, although he's a player in this. Yeah. But the particular ways that autopoiesis, the important roles that autopoiesis has played in developing notions of the agency of living beings, the kind of self-sovereignty of the cell.
Thank you for that. I think you're absolutely right. I think that Lynn Margulis, I think, and Maturana and Varela, these are sort of really fascinating thinkers that have been outside the mainstream of the science, and maybe partly because they've been interested in various ways in the kind of self-making, the agency of self-making organisms and communities of organisms. So I think that's very relevant and important. I'm just thinking that I should integrate that into my epilogue. I have some mentions. I have a mention of Margulis, but probably I should bring them in more as people who were. There's a danger in insisting that Lamarck was out and now he's coming back in. I don't want to overstate that because I don't want living beings such as the ones you mentioned. Yeah, thank you. Thanks.
Well, thank you so much. Great.